Okay, so day 2 of limits. Please ask a classmate to go over the delta from over the weekend if you had difficulty with it. The time it took students to complete it varied a lot. So if you were someone who struggled, please ask a friend. The do now here has us with a graph determining the limits. So at -1, I'm going to look at this point right here. From the left and the right, we approach 1. Number 2, 0, from the left and the right, when x is 0, the graph is approaching 6. +1, +1, I see the point here when x is 1. The graph from the left and the right are both going towards 1. Now a half, it's kind of hard to see. A half would be, I'm looking up from about here. So I'm seeing like around here. But how can we find exactly what this value is? We have the function right here. So if we plug in a half to the function, which we didn't have the graphs, the equations on Friday, we just had the graphs. If we plug this in, -5 times 0.5 squared plus 6, which you could use the graphing calculators, that's what you're going to be allowed for this test, you get 4.75. Okay, and obviously if there's an irrational value here, the square root of 2 is a little bigger than 1, but we have no idea the exact value here. So again, I would plug the square root of 2 in, which in the calculator, it's second x squared. You need to put the radical in parentheses. Make sure you go out of the radical before closing. I forgot the 5, sorry. Squared plus 6, and you should be getting a -4. Okay, so all we need to do is plug in if you have the equation. When we just had the graphs on Friday, again, we had to look at the graph because we had no equation to plug into. Okay, another example here. When we graph this function, we see a graph that looks like over here to the right. So we're going to discuss that after we look at when x is 2, y is 3. Right here I could see it on the graph, or if I plug 2 in, -1 over 2 minus 1, I get 4 minus 1 over 2 minus 1, and you get 3 algebraically, or we can get 3 graphically. The next one, 1, if I look graphically, I see this point right here at 2, but if I try to plug the 1 in here, let's see what happens. We get, doesn't matter what we get on top, once I see that the bottom is 0, it's an undefined fraction. It happens to be 0 over 0, but anything over 0 would give you an issue. But the graph appears to have a value of 2. So how are we going to get that algebraically? So I'm just going to put a question mark here, and we are going to finish it when we do the note card, which I'm going to ask you to put into your flip books. You could pause me and get that done during the lesson. Again, why is this above graph while the function looks rational? When you look at the graph, it looks linear. We discussed this in our functions topic with the holes that you all loved so much. Note card, I need to see what number note card we're up to. I can't even ask anybody right now. 40. We're on number 40. So if you could plug the value into the function and get an output, do that. Do it. If not, we may be able to manipulate the limit by using the dividing out technique. We're going to factor to divide out the common factor and get that simplified function again. And we're going to use the simplified function for plugging in. If you can't manipulate it, then the limit just simply doesn't exist. But for this one, as you see, the graph shows a linear function because of the common factors that cancel out. So evaluate the following function algebraically. Evaluate the following limit algebraically. So again, if we first you're going to try directly plugging in. I would always try to first plug it in without having to manipulate it at all. But we tried that up here already and saw that it didn't work. So once it doesn't work, and I see that the numerator could be factored, it's a difference of two perfect squares, and the denominator is just coming over, I could divide out the common factor of x minus 1. In this case, we're not interested in that common factor. All we're interested in is the simplified function x plus 1. Now I could plug the value in that you're being asked for the limit. I'm going to plug 1 right into there. 1 plus 1, 2, which is what we saw graphically above. So you could take a picture of this and put it into your flipbook. Let's take a look at these. Evaluate the following limits algebraically. I have the graph over to the right to take a look also. Now, always going to try direct substitution first. So when I plug in a 2 into that first function, I get 2 squared plus 1 over 2 minus 1, which is okay. There's no 0 on the denominator. 4 plus 1 on top over 2 minus 1, so it's just 5. That is the limit. If I look graphically at 2, we could see that from the left and the right, they're both going to that same point that must be 5. It's right in the middle of 4 and 6. Okay, if we plug 1 in for the second one, 1 squared plus 1 over 1 minus 1 equals, I see that there's going to be a 0 on the bottom. On top it's 2, but it doesn't matter. This is undefined. So you're going to look to see, can we manipulate this? The top here is a plus, not a minus, so it's not a difference of two perfect squares. So we cannot factor it, and therefore we cannot manipulate it. So this function does not exist. D-N-E does not exist. If you look at the graph, when x is 1, there is an asymptote there. But again, you could see that algebraically. You wouldn't have to see it graphically. The last one, negative 2. Let's plug it in and see what happens. We get 5 over negative 3. And again, you could use the graphing calculators. So 5 over negative 3 is our value. And I could look at the point right here when x is negative 2. It's a little bit more than negative. It's between negative 1 and a little less than negative 1. It's between negative 2 and negative 1. We get that exact value by plugging in. Okay, so we try direct substitution first. In the event it doesn't work, like in the second one here, we attempt to factor. In this case, it wasn't factorable, so it just doesn't exist. Moving on. Okay, no graphs are being given here. Now we're just relying on doing it algebraically. So here I'm going to plug the 1 in over 1 plus 3. I get negative 4 over positive 4, negative 1. That's your answer. Next one, I could see right away that if I plug a negative 3 into here, I'm going to get an undefined fraction. So again, I'm going to attempt to manipulate it by dividing out a common factor. The top looks like it could be an add multiply, but there's no two numbers that multiply to negative 1 and add to 1. So this is not factorable. Again, not factorable. When it's not factorable, and when we plug in this value, it's where there's a vertical asymptote. It makes the denominator 0. Then we're just going to write that the limit does not exist. D-N-E. Next one. Okay. If you feel like you want to try these now without me, you could pause. 1 minus 1 on top. I don't really have to put the bottom in. Actually, I should in case it's 0. 1 squared plus 1 minus 1. And I actually do get 0 over... 1 minus 1 is 0 plus 1 minus, I get 0 over 0. So this is undefined. However, this is going to have a limit because I'm going to be able to factor that denominator and essentially manipulate this. I could divide an x out. I'm going to factor by grouping. Actually, I could divide out an x squared. Get x minus 1. Bring down the plus sign. Bring down a 1, x minus 1. So the x minus 1, the numerator I'm just bringing down. The denominator, I'm going to finish factoring out the x minus 1. I'm going to get x squared plus 1. So the x minus 1's factor out. I have 1 over x squared plus 1. So I get 1 over 1 squared plus 1, or 1 over 2, 1/2. So even though that 1 initially made it undefined, since I was able to simplify the function and get an answer that way, that gives us a limit. Next one, which might be the final one. Oops, sorry. I could try the -1 in there. Always first try to just factor it without anything. And I get 1 minus 1 on top, 0 over, I could put this in the calculator, 2 minus 5 plus 3. So it's -3 plus 3, 0 on the bottom, again undefined. Let's see if I could manipulate this. I see the top has a GCF. So I'm going to factor out the GCF on top. On the bottom, it looks like it could be a a split the middle. Add to 5, multiply to 6. So let's factor that off to the side somewhere. The 2x squared plus 5x plus 3. Add, multiply to 6. So that's 3 and 2. 2x squared plus 3x plus 2x plus 3. I'm going to factor out the x and get 2x plus 3. Factor out a 1. Get 2x plus 3. So I have 2x plus 3 times x plus 1 in the denominator. So there is a common factor that I could factor out. I get x over 2x plus 3. And now if I plug in -1, I'm going to get a limit that exists. 2 times -1 plus 3. So I get -1 over 1, which is -1. I know I went fast, but now you guys could watch it again if you need to. And I might give like a couple questions for a homework assignment just so you could practice. Like I'd give you 2. So you don't have to turn this in, just turn the homework in. Thank you.